Bismillahirrahmanirrahim. Today we will configure MPLS layer 3 VPN as per given topology. All IP addresses are already configured to save the time. Our R1, R2, R3 are service provider routers. Our R4, R5, R6 and R7 are our customer edge routers. Our goal is to transport data from one customer edge router to the other customer edge router through the service provider's network. Multiple customers would communicate with their own branches without any problem of interference with other customers. Let us start our configuration. R1 is our PE router. Configure terminal. First of all, we will configure OSPF router, OSPF1 network 1.1.1.1 wildcard mask all zeros, area 0, network 192.168.12.1 wildcard mask all zeros, area 0. In the same way on R2, router OSPF1, configure terminal, router OSPF1, network 2.2.2.2, 0.0.0.0, area 0, network 192.168.12.2, all zeros, area 0, network 192.168.23.2, wildcard all zeros, area 0. Next our R3, configure terminal, router OSPF1, network 192.168.23.3, wildcard mask all zeros, area 0, and network 3.3.3.3, wildcard mask all zeros, area 0. Let we see the neighborship from our middle router. Our one neighbor comes up. Do show IP OSPF neighbors. Our both OSPF neighbors are up now. One neighbor is up and other one is in process. So our both neighbors are up. Now we will configure MPLS LDP auto. Just one command in router configuration mode, MPLS LDP auto, MPLS LDP auto. Do show MPLS LDP neighbor. Our both neighbors are up. Now we will configure BGP with VPNv4 on our provider edge routers. Router BGP 100, neighbor 3, remote AS same because it is IBGP, neighbor 3, update source loopback 0, address family VPNv4, neighbor 3, activate. In the same way we will configure IBGP with VPNv4 on our other provider edge router. Exit router BGP 100, neighbor 1, remote AS same for IBGP, neighbor 1, update source loopback 0. We have not configured the address family VPNv4 yet in R3, but our neighbor is up. This is due to the address family IPv4, which is configured by default. We may disable it at the end. Now address family VPNv4 unicast, neighbor 1, activate. Yes, our neighbor is up and topology is okay. Now we will configure VRF on R1 and R2. Configure terminal. IP VRF A1 RD 1:1 route target 1:1. This RD value 1:1 and the IPv4 address both will make VPNv4 address, which will identify the traffic of this A1 customer throughout the ISP network, and this value should be unique within the ISP network or service provider network. In the same way, we will configure another VRF for our second customer VRF B1 IP VRF B1 RD 2:2 route target both 2:2 if we do not use the keyword both, this is iOS automatically add this keyword for route target. Next, we will define our route R1 outer interfaces which are associated with these customers and these VRFs. INT F2/0 no shut IP VRF forwarding A1 IP address 192.168.4.1 255.255.255.0. In the same way, we will configure IP address for our other customer INT F3/0 IP VRF forwarding B1 IP address 192.168.4.1 255.255.255.0. You can see here that the interface F3/0 and interface F2/0 is configured with the same IP address because these two interfaces belong to two different VRFs. This is the power of virtual routing. Now we will configure our customer edge routers which are connected with R1. Configure terminal, do show IP interface brief. Okay. We will configure a static route here towards our provider edge router IP route 192.168.2.0 255.255.255.0. This route resides at the other end of the ISP network and belongs to the same customer. Our target is to provide communication between R4 and R6. Next hop is 192.168.4.1. In the same way, at R5, configure terminal, IP route 192.168.2.0 255.255.255.0. Next hop is 192.168.4.1. Now we will configure our R1 again with the static route towards our customer edge router. IP route VRF-A1. Here at provider edge router, we will define the static route with VRF, but at customer edge router we will configure static route without VRF because our customers are not aware of the VRF. IP route VRF A1 192.168.1.0 255.255.255.0. and next hop is 192.168.4.4. In the same way, we will configure a static route for our customer V1. IP route VRF V1, network is same. Next hop is 4.5. In next step, we will redistribute static route into BGP router BGP 100, address family IPv4 unicast, VRF A1, redistribute static. In the same way, we will redistribute static routes of the other customer address family IPv4 unicast VRF V1, redistribute static. Here we can confirm the routes So BGP VPN v4 unicast all. We may see the routes coming from our customers A1 and B1 with route targets 1:1 and 2:2. In the same way, we will configure our R3 router and R6 and 7 router. Configure terminal, IPVRF A2 RD 1:1. At the other end, we have RD for our VRF A1. Therefore, A1 and A2 will be able to communicate with each other. Route target 1:1, IP VRF B2 RD 2:2. B2 will communicate with B1 on the basis of its RD 2:2 because both have the same RD or route distinguisher. Route target 2:2. Now we will identify the interfaces for these customers. INTF 2/0, IP VRF forwarding A2, IP address 192.168.4.3, 255.255.255.0, and INTF 3/0, IP VRF forwarding B2, IP address 192.168.4.3. We are providing the same IP address on both interfaces because they are members of different VRFs. Now we will configure static routes for both of our customers. IP route 192.168.2.0, 255.0, and next hop is 192.68.4.6, and sorry, I forgot to assign the VRF. 192.168.2.0 I will discard this command, and again we will define it with concerned VRF. Our VRF is A2 here, and in the same way we will configure static route for customer B2. Now we will configure static routes from customer to provider router. R6 is our customer, which is connected with R3. Configure terminal, IP route 192.168.1.0, 255.255.255.0, and next hop is 192.168.4.3. In the same way, at R7, configure terminal, IP route without VRF 192.168.1.0. It is the loopback address and loopback network of our other customer edge router. Sorry. Now we will redistribute these routes into BGP. Sorry. Router BGP 100, address family IPv4, unicast VRF A2, redistribute static, exit, address family IPv4, unicast VRF B2, redistribute static, now we will check our routing table of BGP VPNv4. So BGP VPNv4 all, unicast all, all of our routers are present here. Now we will check our one customer edge router to ping the other customer edge router. For example, R4 should ping the loopback address of R6, and R5 should ping the loopback address of R7. Ping 192.168.2.1. source 192.168.1.1. It is working. We will check the network configured for the other customer. Exit. Ping 192.168.2.1. Source 192.168.1.1. It is also working. We have configured the MPLS layer 3 VPN. We can also check it by traceroute command. Trace. At the end, we may see the important commands which we used during the configuration. These are some important commands which are necessary to configure MPLS layer 3 VPN. Thank you for watching.